The topic for this particular presentation is what's in the box. It's a discussion of cartons, boxes, and their benefits as a packaging material. I recognize this isn't necessarily the most attractive of topics, but in terms of importance, packaging with cartons has been around since cartons were developed, both for groceries, now for e-commerce shipping, for full truckload shipping, retail, etc. And it's across every single industry. So the box has been the primary available method for being able to transport products, in some cases animals, pharmaceuticals, whatever it is, and it is the primary thing usually, unless you're shipping in a crate or some other outside the box container, but it's usually the first thing that comes in contact with the environment, whether it's a truck, a pallet, etc. So it's it's literally your primary protection against any other shipping threats in the environment. So just to give a quick introduction about the course, about this business, about myself. So we obviously have a lot of people joining from a number of different industries. This is geared towards helping everyone a little bit in some way. It's obviously a free webinar, so our goal with this webinar is to educate folks so they can go back and whether it is find a more sustainable method of packaging their items or just being able to better understand their data that's coming in from customers or helping design packaging in some way. This is our involvement with the community so that we can help you guys better understand what's going on with your products, with your shipments, and in the supply chain and packaging world in general. Protective Packaging Consultants is a consulting company that specifically focuses on helping anyone who needs it design a better package, look at quality control methods, figure out better ways of fulfillment, effectively improve operations, reduce damage, reduce customer issues overall. So if you have any questions, whether it's during the call, after the call, if you have a problem child of a dresser or of a small lamp or a large vanity, whatever it is, if you have any damage issues that you want to solve by either improving packaging, looking at customer experience, quality control, etc., please let us know. We are excited and intrigued by all of these different problems. We also specialize in data, so if you have any questions about data that you should be collecting, how to collect it from customers, all questions that we'd be happy to answer. My name is Daniela. My background is in working with different e-tailers. I've worked with Wayfair, with Amazon.com. I've also previously worked in warehouses and setting up e-commerce fulfillment sites for companies like H&M, with 3PLs like OHL and Logistics. And I've kind of worked and dabbled in enough different furniture and home goods manufacturing industries as well as apparel to confidently say that if you have an issue, most likely someone else has had that same issue and it has been solved, and there is most likely an efficient way to solve that problem. So again, if any of you have any questions, please let me know through the chat window. You're also welcome to send us an email afterwards. It's propackconsult@gmail.com. That email will come up at the end of the presentation. And again, if you have any questions, everyone's on mute, so all the folks who just joined, I heard a lot of dings. We are recording. This is going to be put onto our website on our resources page so that folks have the benefit of rewatching it as needed, and that means everybody's on mute today, except for me. The best way to ask questions or to let me know if something's going on is through the chat or the message window. So to start the meat of the conversation, we're 5 minutes in, just to make sure we have enough time for everything. Today we're going to be talking about just a general what's going on with cartons, like what is a carton. It's hopefully going to be a little bit more technical than basically what's a box, but I also want to get into the more scientific aspects and physics aspects that go into protecting your products using this paper-based product. I also will cover cartons, so that's more so talking about the environmental impacts on cartons. Some of the information has previously been in other topics during previous webinars. Those of you who have been a part of our webinar series for a while now, welcome back, and you might see some stuff that you learned and we dabbled in earlier on. I will also at the end be giving you some quick recommendations, tips, and tricks that can help you identify whether there's something that you can do in your own warehouse, quickly going back to your factories and confirming that the boxes are being, for instance, oriented the right way, and helping your boxes and cartons and your paperboard, whatever it is that you're using, your fiber-based products, help protect your products for longer in the supply chain. So I bet everyone's really excited, and that's great. This is going to be just a quick slide about how can you figure out what your actual carton strength is. Throughout the presentation, I'm going to be giving a lot of information about just cartons in general and why they're strong, how to make them stronger, etc. But the first part of it starts with how do you find out what your current carton strength is? And there are two ways of doing that, or there are two generally accepted definitions of carton strength. The first one is pressure per square inch, just PSI, and the second one is called edge crush test, ECT. There's something called a BMC, which is a box manufacturer or box maker certificate, and this is literally showing two examples. These circles are box maker, box manufacturer certificates. This is commonly stamped on the bottom of your box on a bottom flap. And if you say, I don't have one, that's because the box making factory that you are using or that your manufacturing facilities are sourcing from are sourcing in a country where this is not required. In the U.S., it actually is required to put on every single box. In the interest of being able to share that information, I guess, it's just part of kind of U.S. packaging law. In other countries, this is not required through manufacturing. So if you don't have this on your boxes that are coming in from China or Indonesia, from India, don't be concerned. Like they don't have to put it on. You can ask them to put it on. If you're getting boxes from the U.S., they should be putting it on every single time, so you'll be able to better understand what the actual strength of your box is that they're using. The things that go into box strength, we're going to go into further detail on, but just things that you're able to see here. You have the bursting strength, so that's burst strength is same pressure per square inch, and edge crush test, very similarly, kind of the top number, the top data point in the BMC, and then it goes into some other information, which is, although there are formulas to calculate this, I'm going to explain a better way of just finding this information throughout your kind of your product line so that it makes a little bit more sense. The most important piece of information is just that top number, whether it's the PSI, pounds per square inch, pressure per square inch in terms of pounds, or the edge crush test. So the important thing to note here is you are talking about something that is comparable, it's not equal. So there isn't a good way to say that there's one box or a PSI that equals an ECT. They're extremely related, but the PSI actually means the bursting strength of the box. There's that is actually measuring the amount of force it takes to puncture a box or have it blow out, as opposed to an edge crush test, which measures the amount of vertical stacking strength, so to speak, on one edge of a carton. So they measure slightly different things. That being said, if you're making your entire box out of the same material, which the majority of boxes on this planet are made out of, it'd be really confusing if they weren't, you most likely are able to correlate those very, very closely because it's the same material. You're just measuring two different aspects of the strength of your carton. So that is probably the least fill slide. We're going to go into some math here. And the reason I want to show you the math part of this is because, A, I want you to understand how you can calculate this on your own, but B, also understand that there is an element of an element of estimation on this. So this is also showing you under ideal conditions how strong your box is. An ideal condition means there's no humidity, it's coming right off the line, nothing has applied any pressure, fatigue, or any potential disastrous consequences into the strength of your box yet. So most likely it's literally just coming out of a die cutter or a machine, and your box has just been made out of hopefully virgin fiber, as opposed to a weird, I shouldn't say weird, just a recycled material or a material that has some sort of variety to it, either making it waterproof, etc. That kind of changes this formula. So this is just a clean box, comes out of machine. And so there's this McKee formula. It effectively says that this constant, which has been debated on for many years on whether it's valid, how it was determined, etc. But just take my word to say that there's this constant number associated with this formula. So the compression strength equals 5.87, which is that constant, times the edge crust strength, or the edge crust test value of your box, multiplied by the square root of the board thickness, that is multiplied by the load-bearing perimeter. So square root of T multiplied by P. And I've listed these out so you can look at this later. So an example of this is if you have a C-flute box, and we'll talk about fluting in a second. Whatnot right now is just for you to understand where some of that BMC number from the edge crust test can be used for to figure out what the actual strength is of your box. You have a 10 by 12 by 12 box. You figure out what the load-bearing perimeter is, so effectively what part of your box is bearing weight. We're just estimating that 44 inches is your load-bearing perimeter. If you plug that into the formula, in theory, your box can bear almost 500 pounds of weight. And that's a lot. That's a pretty impactful amount, especially if you're floor loading something. If you're in the warehouse, you don't have enough racking, you're maybe putting these on the floor and stacking them really high. My big note on this slide, though, is remember, this is an ideal condition. This is a directional estimate. So there's a variety of data out there. There's a lot of research that's been done on what amount of strength is lost over a certain period of time with boxes absorbing moisture, dealing with altitude, cold versus hot. And in general, I'm just going to tell you, over time, boxes lose a lot of strength. If you have a product that's able to move around in your box, which came from one of our learnings from one of the past seminars last month, if you have something beating up your box from the inside out, if you have humidity in the southernmost part of the U.S., if you're also dealing with boxes that are incorrectly stacked upon yours, that means this 500-pound number goes out the window, and it's not going to be, that box is not going to be able to bear that 500 pounds that this formula is providing. But that being said, you can work backwards to say, how much do I need to anticipate my box being stacked upon? I anticipate that there may be, based on my stacking method in the warehouse, 200 pounds of weight sitting on this box of dinnerware. Working backwards, you can calculate the ECT you need. And just remember, this formula only takes an ECT, so don't accidentally plug bursting strength in. Don't plug that PSI number in. So two very different numbers. PSI is always going to be a very high number, like 200 or 275 or 350, whereas ECT is going to be 32, 44, 48. Two entirely different numbers, meaning if you use the wrong one in this one, you're going to have a really bizarre amount of compression strength. So again, if you guys have questions about this, please just type it in the chat window, and I will try to answer them. Just because we're switching topics kind of from slide to slide, I'll try to answer these questions as they come up, or if it's just a general question, I'll save it till the end. But if you have questions at any point, please let me know. So we talked about in the past slide, you need to know the flute thickness to be able to input that into the formula. The great thing about it is Google's a wonderful thing, and Google has all that information. So if you know that you have a ECT, a carton that's 32 ECT, and you have an A flute, you can just Google that and say, I need A flute thickness, and they'll give it to you. The other great thing is I gave it to you. It's at the very end of this presentation in an appendix. So if you really need it, this presentation will not only be posted in video format where you can hear me again, in case you didn't get enough of me now, but you can also download the actual PDF of this presentation and have that for your records in case you need it in the future. So Google, me, all great resources. You don't have to memorize the flute thicknesses, thank goodness. So in this case, your flute types, there's a variety of flute types. There are very, very thin flute types, and there are very large flute types. And the flute is actually, the fluting is that wavy piece in the middle. So similarly, if you look into the magnifying glass in the single-face corrugate, the fluting is just that wavy part, and that is what makes up the strength of corrugate. And so flute type is the thickness or the amount of space from wall to wall in a piece of cardboard. You don't have to have both walls, but the thickness will be determined by this lettering system. And this is a simple and universal system that works with manufacturers wherever you go, whether it's in the US or overseas. So if you say, I need an A flute box that's 44 ECT, they're going to understand what you're talking about. Moving on to the cardboard wall options over here in this section. So this is, I shouldn't say this is all cardboard, but these are different types of board, and this one is probably one that you guys have seen in terms of a cosmetic protector or something to just wrap with, as opposed to actually making a box. It'd be really difficult to have a structural component to this box because the fluting would very easily be crushed, but it's a great packaging material, and it works similarly to how thin foam coverings and small foam bags work, except in fiber format. So single-face corrugate has one wall and one set of fluting. Single wall, which is this photo down here, it has two walls, one on each side, and it's sandwiching some fluting. So single wall is a misnomer because there are actually two walls. It should be single flute, but so far the packaging industry hasn't wanted to rename it based on my preferences, unfortunately. The double wall actually means that you have two layers of fluting, but you have three walls. And triple wall corrugate means that you have all of these different layers. You have three layers of fluting, and then you have walls that surround them and go between them each time. So most boxes are going to be made out of either double wall or single wall, depending on where you're manufacturing the box and how much weight is going into it. In terms of the strength, the puncture resistance versus the edge crush strength of the box, double wall has more puncture resistance in general because it literally has more material between the three walls that we're talking about. So that's this one. I think this is pretty logical, right? Like you have more material, it's harder to puncture through it. That being said, you can have extremely high strength single wall material because the walls themselves are made out of extremely rigid, high quality paper. The fluting is also made out of high quality paper. You have good adhesive, the glue that's mixed in there. So you could have cardboard that's strong enough to build furniture, build houses potentially. There's just a lot of opportunity here. So don't just infer that a thin or a single wall is extremely weak. That's not necessarily true. You can have really low quality material in a double wall, making it less strong than the single wall in some cases, depending on the type of board that's used, depending on the type of material that's used, etc. And all that is defined by saying, I need this strength made out of these types of flutes, and I want this many walls in the box. So double wall versus single wall versus triple wall. So again, if you have questions, let me know through the chat window. Hope this is helpful so far. If you guys are hoping to hear about something, again, you have a question about something, I'm happy to add on more information into this. We don't have to just stick to the slides. Just let me know. So the next part about this is again, we're still in the definitions part. The majority of this presentation is still definitions. So we'll get to some of the conclusions and tips and tricks later. But I wanted to spend a little time defining the load-bearing areas, because I think this might be the most important thing that I leave you guys with today. So for those of you who are not paying attention, this is the thing that you want to snap back and really pay attention to, because this is what's going to impact your warehousing. It's going to make or break the success of how long your box is going to be strong for. And if you are seeing a lot of crush and collapse in your warehouse, cartons aren't even making it out the door without having wear and tear, this may be a solution that costs you very little to implement that ends up reducing damage really considerably. So the strong part of the box is going to be obviously corners and edges, but the parts of the box that are bearing the most amount of weight are going to be the corners of the box itself. The middle portions of the box is actually the large bearing surface areas of the box. They help keep everything together. They keep your product contained. They keep your product from making some crazy T-Rex maneuvers and escaping from the box, but they're not bearing a lot of the weight. So if you were to put a bowling ball in the middle of that box, as opposed to putting it on one of the actual vertical corners or edges, the bowling ball is much more likely to fall through in the middle than it would be on the perimeter of the box. So on this image of this box, the green is the structural support of the box. The yellow is the most strong portion, is the absolute strongest portion of the strength of your box. So the parts that are most likely to be punctured or explode out, these are the blowouts, especially when there's a intended or unintended closure, which is a flaps. So you might have access points like handles, and those handles might be on the sides of your box. And those are places that the strength is reduced because you've taken out material. In this case, you've cut the material on at least 2 spots of your box for flaps to open, which obviously is necessary because otherwise customers are going to be very confused. But that also means that whatever strength within that box side, it's even further reduced in those cases. So obviously, a lot of this is logical. I just want to make sure for the left portion of the slide, the important thing to remember is your load-bearing area is on the corners and edges, but mostly the corners of your box. In terms of the fluting, the flute direction becomes extremely important, because if you have your fluting pointed the wrong direction or oriented the wrong direction, it literally has very little strength. Like, you will be effectively crumbling your box just by putting any amount of weight on it, because it doesn't bear weight at all on that side. So these are the 2 examples I was able to find very good, what I think are very good sneak peeks to the fluting without me tearing open a box in my office. Figured this was a little cleaner. So in this left diagram, the flutes are going horizontally. They're going effectively perpendicular to the stacking strength requirement of this box. So if you were to put this on your shelf and you were to stack more stuff on top of it, you're going to see these linear bulges where you can actually see lines going across your box, and they will be visible because your box will be buckling. If you see that, either A, there's a whole lot of room in your box, or B, your box is oriented the wrong way. If you were to flip that carton, or flip the manufacturing method of that carton to be vertical, in this case right here, you would be able to use the strength already existing in that box and stack on top of it, thereby creating a huge amount of strength in these corners, in each one of the edges. Whereas in this case, yeah, you have a corner, you have an edge present, but they have no structural support of which to be able to put pressure on, which is the sides. So if you are putting anything into stock this way, don't stack on it, because as soon as you start buckling on the ridge lines, on the fluting lines, you can't unbuckle them. Once it's buckled, once you put it into a truck, onto a FedEx truck to ship to a customer, in that particular area of the box, you've lost the majority of the strength, you've lost the structural integrity there, and it will keep buckling there over and over again. So the best way to have a carton retain strength going into the shipping journey is to not have it lose strength beforehand by orienting it the wrong direction, potentially adding any cuts or anything into the box unless it's intentional, like having hand holds, which I'm not opposed to. Just want to make the note there. I have to tell you that cutting out any portion of the box or cutting into it has it lose strength. The benefit can still outweigh the amount of strength lost. But if you notice that there are any cartons that are buckling, that are fatigued, the corner's already crushed on, you're just sending those out with much less of a chance than a much better taken care of box would have going into shipment. And this is the reason why, because you are impacting the strength of the fluting and of the actual structural components of your carton. So I'm going to move on to the next slide. If anyone has questions or anecdotes or anything that they want to share, just let me know in the chat window, because every time I visit a warehouse, I shouldn't say every time, 98% of the time I visit warehouses, this is an issue. I have visited in the last 5 years probably over 400 warehouses. And I've given, during the last few seminars, or webinars, I should say, I've given examples of some of the issues that I've seen, and they're not always as pervasive as this one. Fluting direction, stacking, orientation, and keeping your boxes alive longer to add and keep that protective strength is something that I have to harp on repeatedly with every one of the clients I work with, because almost everyone has a couple faux pas in their warehouse that either due to size limitations, stacking limitations, space, etc., they're breaking some of these orientation and fluting rules, and by doing so, they're compromising the integrity of their cartons. And unfortunately, they're shooting themselves in the foot. So it's something that as business folks that you walk out, you know the cost associated to damage, you know the cost associated to having a customer upset or potentially walk away from your business because they've received something that either looks really miserable, where the carton just comes in, even if the product is okay and the carton just comes in so shabby and torn to pieces that they're not impressed by you or your brand anymore, or the product arrives shattered, the box looks terrible, and they're like, why are you shipping me this terrible, miserable looking stuff? There's a way to avoid that, or at least give your box a much better chance going into the very terrifying world of the shipping environment that is UPS, FedEx, LTL, full truckload carriers with all of that machinery, and that way is by abiding by some of these orientation and fluting rules. So I quickly want to go through and just talk about boxes in general. So if you guys know this already, I recognize that some of you work with boxes a lot, you're purchasing managers, some of you design beautiful products but don't really know that much about packaging. So I'm sorry if this is a reiteration on some of the things you already know, but I want to make sure everyone's on the same page. So there are 4 of the most common boxes on this slide. I also recognize there are many cartons that are more customized to unique products, and they don't fall into this category of just general carton types. So I'm not going to talk about them. I want you to know RSC, which is a regular slotted container, an FOL, a full overlap slotted container, and a 5-panel fold, and an FTD, which is a full telescoping. The reason these are important is because most likely every single one of you has used an RSC before, and an RSC is the most frequently made type of box out there. It's incredibly helpful because it collapses easily. It uses a standard amount of material that you can design so that you don't have a lot of cardboard waste. Unfortunately, if you don't design the RSC correctly, again, this is one of those boxes where there's strength in the corners. If you don't use it correctly, you lose that strength and potentially compromise the structural integrity of your product as well. And FOL is great for avoiding punctures, especially for things that have upholstery on them or fabric you don't want the customers to cut into. It also adds strength because you have those overlaps on the joints. It actually adds strength both stacking-wise and puncture-wise because you have that overlap on the top and bottom. The 5-panel fold carton is extremely helpful when it comes to customers needing to keep their products in the box for containment. It's not as strong as an FOL or an RSC, and because of that, it's not going to yield the same amount of structural corner and edge strength and for stacking as an RSC would, for instance. On the other hand, it's really customer friendly in terms of being able to pack products into a 5-panel fold box. So for instance, flat packed items or mirrors or just products that have a lot of flat components in general. And then it's relatively simple to send it to a customer and have them open it in a way that doesn't require a packaging explosion all over their living room. That being said, as I said before, it's not necessarily as strong. It does have some good overlap in terms of having the corners have multiple pockets and pieces, but again, as the more times that you cut into a box, the weaker it gets. This has a lot of cuts in it, unfortunately. And then an FTD is a full telescoping box, so it's a top and bottom. It's kind of like a shoebox. This one's pretty strong. It just ends up being both confusing to customers on how to open it if you don't provide them a lot of good information. It's definitely customer friendly because you can slide the top on and you still have, slide the top off, and you still have something containing your product and all its packaging. But it's really time consuming to pack, specifically to have whoever's on the end of your line to be able to slide one of these over the other. And it's also difficult to tape it closed. So again, a lot of these are still definitions. I know we haven't gone into a huge amount of how this pertains to you, but this is a slide that, in combination with the fluting slide that we talked about, is really helpful for those of you who are looking at ways to improve your warehouse operations, shipping, ways to bring product in. So I just want to talk about two different types of stacking methods: column stacking and interlocking stacking. The reason stacking is so important, as I'm sure that you guys already know or are able to draw a conclusion on based on all of the harping and the high horse I was sitting on with the fluting conversation. But with a box having very specific points that are able to bear weight, if you stack your products in a way that uses those points, you can have a much stronger stack that doesn't collapse as easily, which means putting product away, taking it off of trucks, etc., is going to be a lot faster, especially if it's on a pallet that isn't tearing the one side or collapsing. On the other hand, there's always a question of how can we fit more onto a pallet, and sometimes methods are used to fit more onto a pallet that require boxes to bear weight in places that they are not strong. And because of that, you're compromising the integrity of your carton, but benefiting on your utilization or the amount that you can fit onto that pallet for shipping. I recognize it's a business decision. I'm always going to lean towards the side that says better for packaging. You can add in an extra truck, and ultimately your products are not going to get damaged as frequently because you're taking better care of your boxes. But I also recognize, based on cost, it might be better for you to create a method where you are putting things on their side or stacking in a weird way, like an interlocking stack. So to go quickly over the column stack, you're effectively duplicating the strength from one box, and you're choosing to place the next box directly onto that strength. So it's corner to corner, corner on top of corner. And if you add stretch wrap or straps, you're adding even more stability and strength because you are pushing edges and corners together in addition to gravity holding them down. An interlocking stack is where you turn the box on each layer of the stack. And because a lot of these have a weird fitting mechanism, you can see on these that on this picture where you have some boxes are lower than others based on the pallet or based on that box height, etc. And this is all the same product, by the way. Like, this is the whole point in having these two side by side. But depending on how much you tape or whether you accidentally shove one flap closed on top of one another versus them meeting in the middle flat, you could have a whole variety of strength and where those corners are actually hitting your carton. So it's just something to think about. In these cases, a lot of the times the corners are not landing directly onto corners. And as I said before, corners are the strongest thing that you have in a box. So if you have products sitting on top, so if these are, if this is 70 pounds a piece, and this corner is landing in the middle of your box, you have a surface area in your carton on this end that's bearing weight, but you also have another surface area that's not only bearing weight, it's pushing onto an area that has a lot more strength. So you could have force coming up this way and coming down this way, and you're crushing this middle box as opposed to the bottom boxes on this stack. So it truly does depend on where is your box bearing weight, and it could be that out of a stack of 10, the top 2 are having problems underneath the top one getting stacked as opposed to the one on the bottom because of the stacking method, whether there's a corner on a corner, an edge on an edge, something puncturing the middle, one of them potentially being fluted the wrong way or turned onto their side, whatever the situation is. But I always recommend column stacking whenever you can. Interlocking stacking, I understand it leads to more stability, but I would rather give you a recommendation on how to make your column stack more stable as opposed to using an interlocking stack and potentially collapsing boxes. So those are the definitions. The next section I'm moving into is just common issues that are going to affect your boxes in general. I'm sure that you guys in your returns, or if you do have a reverse logistics process, you're seeing some of this stuff come back to your warehouse. There's also, obviously, you're getting photos from customers sometimes, and some of these photos actually came from previous webinars as well. So punctures, indentations, and then general moisture, fatigue, collapse, etc. These are the 3 biggest things that affect cartons. With punctures, you obviously have, in this case, the puncture probably came from another box falling into it, and that would be the corner of that box right there. It crushed that side, it tore it. There are some, when another box is attacking yours and it's stronger than yours, it's probably going to win and it's going to take a chunk out of your box. I don't want to necessarily talk about animal fighting, but you can think about it that way, and even though it's absolutely terrible to give that example, but the stronger, the meatier, the heavier box, unfortunately, is probably going to win against a weaker one. So in terms of designing your packaging, you have to think about, for your carton, choosing a carton strength, how heavy is your item? Are you shipping it on a pallet with other items, or is it going onto an LTL truck where there might not be a lot of ability to control what's going on around it and what's going into the truck around it, and whether those other suppliers are adequately immobilizing their product from knocking into yours. The next photo shows that in this case, a supplier that I had visited was putting strings around their warehouse stacks in an effort to prevent them from falling over, because they both ran out of space but also didn't have a lot of racks. And so they chose to floor stack really high, and because of that, their stacks got really teetery because they were column stacking it. And instead of reducing the height of their stacks or making racks, or using V-board or adding any like actual stacking strength to either their boxes or the method of stacking, they chose to try and keep the stacks really tightly pressed against one another. And it cut into their boxes. Once you cut into a box, as I said before, once there's a crease, it's not coming out, and that's going to be a weak spot. So there's a crease. This edge is supposed to be this is 2 corners, right? This whole edge is supposed to connect to 2 corners. Corners are the strongest things. Now those corners are pretty useless, unfortunately, unless you turn the box over. And in that case, you're probably going against the fluting, because most likely the fluting, it should be going in a vertical up and down direction. So in this case, you've compromised at least two full sides of the product, probably more at this point, and you've compromised at least one edge that we can see, which means you've compromised at least two corners. I'm guessing it's at least four corners, because most likely the other side of this box looks the same as this one, this side does. And so if you think that this is maybe in the bottom of a stack of boxes that are 15 tall, that's why your stack is leaning most likely, and you're going to have to take a lot more action, corrective action, to prevent that stack from falling over, which probably is going to compromise those boxes. And once you pick them for customer orders, they're not going to look very good. They're going to leave your warehouse looking like this. So I can only imagine how they're going to end up at the customer. They're probably not going to be happy. In terms of moisture, you can actually see here all of this. And this is an image from Google. I just wanted a photo of a really, really low quality, low strength box that had absorbed water. And in this case, you can just see where this thing, you could probably put it in the palm of your hand and crinkle it up like a tissue, unfortunately. So really low strength, easy to tear. And these boxes, they generally aren't very good unless you're using them as separation between components. They're not very good as a shipping container. So again, for those of you, I heard some beeps of folks joining. If you have questions, please use the chat window, and I will move on. I hope that you guys are so far benefiting from at least some of this information. So we're just moving on, continuing to talk about common issues affecting packaging, and I want to talk about force. So we talked to, if you are curious and you hadn't joined the there are a couple webinars before this one. We talked about packaging materials, and we also talked about just common issues relating to packaging as it comes to the distribution environment. They're on our website. Again, go to our resources page or email us. I can send you a link to those. This is how the inside of your product ends up killing the outside of your box, unfortunately. So if you have movement inside of a box, and this is just like a small ball that's dense with a little animation that I created, every time, like you might have an extremely strong box here, but if you have movement, you're going to crush a corner by hitting the ground, but then your product is also going to hit the ground. So after your box rebounds, which all things do, it hit a force that was greater than it, which is the floor or a foot or something, a forklift, it's going to start going in the opposite direction. So as this box moves up, this product, due to gravity, is still probably moving down. So it is going to hit the already crushed corner, and now that box is going to start moving downwards again, whereas that product, having hit something that stopped it and probably reversed its force, adding some energy into it, the product is going back up, whereas now the box is either going down or is in limbo or it doesn't know what's going on, and it's like, why is physics doing this to me? I'm getting beat up over and over again, both by whatever is outside that I've already hit or could be hitting again as I'm bouncing, and the thing that's inside. And so ultimately, once whatever product is inside comes to rest and the box comes to rest, you'll find that there have been multiple impacts. You've exponentially increased at times the amount of energy or the G-force that has resulted in this corner having seen at least a collapse, if not the product getting damaged. So this is an example of something where most likely there was movement inside of the box. It actually punctured the closing aspect of the box. So you have the flaps here. Even though it says fragile, I generally don't put my money on fragile stickers of any kind. Everything is fragile, therefore nothing is fragile. And so this box has burst open. If this is something that had a heavy hardware pack in it, there's a chance that that hardware pack might have escaped. And this box is most likely not going to be able to bear weight on the side anymore because there's no there's no strength left to the side. There's no structure. It's curved. That means most likely if there's more weight literally in this box because stuff shifted, that curve is going to hit the ground next time before a non-weighted side, maybe the other side that no longer has the bowling ball in it or whatever was in this box, it's going to hit. So the part of your box that is compromised might actually be taking more hits than the side that wasn't compromised because it was compromised, as ludicrous as that might sound. So I get that every case of damage might be a little bit different depending on what the packaging is like, how much fatigue internally has already happened to the internal packaging, and then what exactly is happening to the outside. Each one of those creates like a very unique car accident, so to speak. And ultimately, the things that data shows are the most heavily affected portions of those unique accidents, or in this case, impacts, are usually the corners. Regardless of how your product moves, once the corner damage happens and your box is compromised in that area, it's going to continue being compromised. So now that that side doesn't have any stack strength, or that corner doesn't have stack strength, if it's stacked into another pile from one shipping facility to another, it might continue to crush and crush and crush. So now not only have you had corner damage, now your product internally may be bearing weight when it shouldn't have been, or the rest of the corners on that side are starting to give, and your edge is starting to give, and now you have one side of the box that's sloped, and you might be crushing that part of your product. And that's ultimately, ladies and gentlemen, is how damage happens. It's just one thing that continues to exacerbate until it fails, and then that causes failures in other aspects of your packaging. So another thing that causes that type of domino effect, as I talked about before, is stacking and crush fatigue, meaning you have a box that has something on top of it. It might be a smaller footprint product, and because RSCs are the most common types of boxes in the world, usually the part that collapses is the flap, the taped closure, and the part that you can see that has bowed outwards are the sides. So your box becomes a slightly more rounded shape. You might have a cave-in on the top. Just think if you have a box that contains mattress or bedding, and then on top of it you put heavy gym equipment. That's really dense, but a much smaller footprint. So a couple slides ago I said, if you walk through your warehouse, you might actually be able to see this. And I made the example of you might have incorrectly fluted boxes if you see these types of bulges. On the other hand, this buckling, even if you have your boxes oriented the correct way, you might still see this type of buckling and box rounding, even if you have that fluting going, parallel to your stacking need. And this is a reason for it. Most times when you ship your product LTL or through the ground, the shipping environment does not care what size your box is nor what's in it. They care to move it from place to place as fast as possible, ultimately. So if you are, as I said before, if you have a very large box that presents a really large surface area, it means that's a really good stacking table for other boxes. And no one is going above and beyond to try and put the exact same size surface area box for that side. Like, they're not trying to get a box that is exactly the same size as this box to sit on top of yours. They're just putting a smaller box on it, or at times they'll put a bigger box on it, which means that box might get collapsed because they put something on that one that's smaller, and now they have a pancake, and it's going to be a box that's smushing out, like if you press, a really filled sandwich the wrong way. Like, it's just going to shoot tomatoes out the side, unfortunately. And the same thing happens to your boxes. So in these cases, these are visuals that you can go into your warehouse and see if you potentially have an internal packaging problem, have an external packaging problem, a stacking problem, etc., and we can help. So tips and tricks, as we get to the end of the seminar, I want to have time for questions if anyone has them. So here, I'm just going to rattle these off, and if you have questions, we're close to the end, so just hold on and we'll answer them in just a second. So first, match your fluting direction with your stacking direction. If you want to stack 10 boxes on top of yours, make sure that the flutes are in a column formation. Similar to building a house, you're not going to put your load-bearing beams laid flat on the floor, you're going to put them upright. try to address the type of box and the product that you're putting into it to choose your stacking method. So if you have an extremely dense product, like you're shipping bowling balls, think about the type of box you're putting it in, and then use that formula to figure out how much you can safely stack on an ideal box, and then cut that estimate down by like 30%. Make sure no cartons overhang your pallets, similar to another box. So the example that I gave of the small box being the bottom box and then the larger surface area box being on top of it, that's the same thing that happens with a pallet. You're going to have the box that's sitting on top of the pallet start to crumble over and fatigue over the edges of the pallet, and you're going to see a whole lot of damage from that because most likely that pallet is going to get run into a wall, that edge is going to get crushed. Now there's no stacking strength, and it goes on and on. It's a terrible downhill spiral. Orient products to help with stacking strength. So if you know that your box has a stack strength that is going to not use the strength of your product, like if you're putting your dresser on your side or on its back to match the stacking strength that you need in your warehouse, you're probably not doing your dresser a favor on pushing on the drawers or anything. Like you should put that dresser upright and then match your box's fluting strength to it. Make sure that you use the correct carton for both the structural protection and the customer experience. So think, what is my customer going to do with this box once they get it? Are they going to sink a blade into it and cut into my product? Are they going to have trouble finding a spot to actually open it easily? Are they just going to try to slide a giant mirror out of the top instead of opening it flat and then being able to lift it out normally? So pretend you're the customer in those cases, but also think, okay, which way, if I design my box to be opened flat, which way do I need my orientation to be? How am I going to store it in my warehouse? Make sure you use effective carton closures to prevent flaps from opening and tearing on the carton conveyors. So if you use really crappy tape, most likely your boxes are going to open in transit. They're going to get stuck on stuff. And they're going to get torn. Your products are going to fall out. Don't do that. Customers like getting stuff in the mail, not empty boxes. So use high-quality tape. There's pressure-sensitive tape. There's water-activated tape. If you need a recommendation on what type of tape to use, or if you think that the data that's being reported by your customers may be indicative that your products are opening up in transit, you might have the right size box or the right strength box, but something's going wrong. Let us know. We can make recommendations to help you. And help handlers by adding access points and instructional directional signage. So make sure that you are putting yourself into the handler's point of view. If you have a box that weighs 110 pounds and that's the size of a small table and you're shipping that through FedEx, it's going to be really hard to handle that by hand, and there's no guarantee that they will use equipment to do so. So add some handholds, don't add straps. If you want to know why, check out one of our previous webinars or email me. Just consider things might get dropped on a corner because they weren't handleable in the first place. Some of these last ones are, help customers by providing simple unpacking instructions, especially have a reverse logistics method where you allow product recycling, or if you're trying to create an easy buyer's remorse out for them that you have a returnable carton or anything. Just keep in mind that you do need to add some printed signage on the outside of the box before your customers incorrectly sink a butcher knife into it. And as I said before, estimate that carton strength is reduced 30 to 50% over time. The longer the amount of time or the amount of humidity, plan for the worst, right? Like it gets, the longer the product sits in your warehouse, the weaker that box gets. And so kind of work backwards in your supply chain to figure out, okay, if I know that my products on average are sold, my warehouse turns over 3 times a year, so your products might be sitting in stock for 3 months on the shelf. Add to that the additional 3 days for shipping to the customer and then several weeks of shipping on the ocean from a manufacturing facility if you manufacture overseas. Your products may need to withstand and retain strength for 4, 5, 6 months at a time, and consider that when making purchasing decisions for the strength of your boxes, that ECT or PSI burst strength. And then make sure that you're using data to identify carton failure points. If you want some suggestions on how to test your boxes, either free of charge or whatnot, just let me know. and we can absolutely set up and help show you how you can create some environmental stress tests, even in your own facilities. So here's an appendix. I'm not going to go through it. If you want to know the fluting type versus it, or you want to correspond your formula to figure out the different types of fluting, here's the thicknesses that you can use in that formula. And then here are some equivalencies of ECT versus burst strength. So burst strength versus ECT, remember I said they are on this, they're similar to each other, and one usually creates the other, but they are calculated separately. So just take it with a grain of salt. And that is the end of our presentation. We have a couple minutes. If you're interested in learning about pellets, we have another webinar